Okay, section 2 of the review, the word problems. There are only 2 of them, but I do believe that the second one's going to get kind of cumbersome. The first one, not too bad. You just can't be intimidated by the words. Let's see. A plane flies from city A to B and then turns, and I gave you the angle that it turns 20 degrees and heads towards C. And we know that A to C is 300. How far is it from city B to city C? So the unknown information in this problem is, I want to know how far it is from city B to city C. This is our unknown. We're looking for that. So ultimately, I want to solve for X. The problem is I don't have the information needed right now. I just don't like my X. Now, whatever. To be able to solve for that. So we're going to have to play around a little bit. And one thing we're going to have to do is we need an angle inside the triangle. The 20 degrees that I gave you is actually right here. So what I'm going to do with that, I noticed that this is a straight line right here. If I go all the way through A onto this dotted line, from A to B through that dotted line, that is a straight line, which means a straight line. That is a straight line, which means this whole thing has to be 180 degrees. That green angle I just marked must be 180, meaning this piece inside the triangle is going to be 180 degrees minus 20. So this angle, which I'll just call y, I know that y is going to have to be 180 degrees minus 20, and I'm pretty smart. I know that that's 160 degrees. So y is 160. And then I'm going to use that to try to work around to solve for x. In all of the things we have, whether it's law of sines, law of cosines, in order to solve for a side length, you're going to need its opposite angle. So before I can solve for x, I'm actually going to need to solve for this angle right here, which I'll just call it A to be consistent with the labeling of the triangle. And the problem is I can't solve for A yet. What we're actually going to have to do, we're going to have to go the long way around the world. I'm going to actually have to solve for angle C first, because based on what I have, that's all I can do. I, I have an opposite angle of 160, which I'll erase the y. I'm going to call this 160. And what I can say is 160 over 300. So sine of 160 over 300 would equal the sine of C over 100. And then we will cross multiply that, and we'll punch that in the calculator to get an answer for the angle C. Okay, so I solved for C, and I got 6.546, and I'm going to store that in my calculator for C. And 6.546 seems like a small angle, which it is, but consider that a triangle only has 180 degrees, and 160 of that is wrapped up in this one angle right here at B. So there's only 20 degrees left between A and C. Once I find C, angle A is going to be easy because A is simply going to be 180 degrees minus the 160 that we figured out minus the 6.546 we just solved. We'll throw that in the calculator. 180 minus 160 minus that angle, which is C. And I got 13.454 degrees. So there's my angle A. And I will store that in my calculator for A. So that is now stored. And then I need to solve for x. So this is 13.4-ish. And now I can finally set up the law of sines to solve for x. And so I'll do sine of 160 over 300 is equal to the sine of that angle I just got for A, 13.454 over x. And then I'll cross multiply that and solve for x. There we go. So I set it up, I cross multiplied, I divided by the sine of 160. I threw all that in my calculator and I got 204 miles, 0.075, and do include units because they were provided in the problem. And 204 makes sense. 13.4 was my middle angle, so I should get something between the other two sides, which I did, so I'm happy with that answer. Okay, number 8. Here we have some crazy lake. And and I give you the side lengths of the lake. There are 5 sides, and I give you a couple of angles in the problem, and I want to know the area of the lake. Now, this one's going to be a little bit of a hassle, but we're going to have to divide this into 3 triangles, and we're going to find the areas of all 3 triangles. We'll have triangle A, we have triangle B in the middle, and triangle C. You can call them whatever you want, but I'm going to call them that. Uh, Triangles A and C are going to be the nicest because those 2 triangles are side angle side triangles. Remember, when you're doing area, if you're going to do area, you either need base and height. So our needs are one, if you have the base and the height of the triangle, that's the easiest because then you can use 1/2 base and height. Um, so base and height. If you don't have that, then you need either side angle side or um, yeah, side angle side, or you need side side side. And if you look at triangles A and C, I do have 2 sides and the angle between the 2 given sides. So those 2 triangles are going to be nice. So my area of A, and the formula for the area of A is 1/2. It's your side lengths, 100 times 125 times the sine of the included angle, sine of 50 degrees. That's going to give us our area for A. For C, it's the same setup. We have 2 side lengths and the angle between them. So the area for C is going to be 1/2 of 70 times 50 times the sine of 100 degrees. So let me punch those in real quick. All right, so I punched both of those in, and I am storing these along the way because in the end, I'm going to have to add all 3 of these areas, and I want to make sure I have the exact areas. So I stored those for A and C, respectively, and I figured that made sense because they are triangles A and C. Now, B is a little bit trickier because B, the only dimension we have is a side length. So if I look over here, I either need a base and height. It's going to be really hard to get the height. So I'm thinking I either need another angle and a side or all 3 sides. And in this case, I think side, side, side is going to be the easiest one. So I'm going to solve for this side length, and I'm going to solve for this side length. And the way we're going to solve for those, for x, I'm going to look only at this triangle right here, and I'm going to solve for x based on that triangle, and I can use the law of cosines to solve for x because I've got this angle and its opposite side, I don't know, but I do have the other 2 sides, so this is a law of cosines problem. Since x is by itself on the opposite side of the triangle, I'm going to solve for x. That'd be x squared is equal to 100 squared plus 125 squared minus 2 times 100 times 125 times the cosine of the given angle. And to solve for y, we're actually going to do the exact same thing, except for y, we will look at just this triangle, and we're going to kind of ignore all the rest. And solving for y is going to be same thing. Y is opposite the angle 100, and so I'm going to set up the law of cosines. Y squared is equal to 50 squared plus 70 squared minus 2 times 50 times 70 times the cosine of 100. Good, 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 good. So let me pause and figure those 2 things out. All right, so there I solved for x and y, and I punched it all in the calculator. I did, and this is kind of a change of what I've done with the law of cosines in the past. In order to go ahead and solve for x, I went ahead and took the square root and just punched the square root of all of that in my calculator at once. Normally, I would work it out and get the decimal approximation for this and then take the square root after that. But in case you're wondering how I jumped straight from all that to just x, I went ahead and took the square root. So let me get rid of all this stuff up here now. And we know that this side length this was x, that's 97-ish. And that's stored for x. I did store that for x in my calculator. And 92-ish is stored for y. And now I have a side, side, side triangle. and that is triangle B. So we had triangles A, B, and C. The way I'm going to finish getting the area for triangle B is I have to use that side, side, side formula, which is Heron's formula. And if you remember Heron's formula, the first thing you have to find is that pesky thing called the semi-perimeter, which is 97 plus 92 plus 50, all divided by 2. It's half of the perimeter. But remember, 97 and 92 are stored for x and y. So when I punch that in the calculator, I'll simply type in x and y plus 50, all divided by 2. Okay, so I plugged that in the calculator and I got 120.286 was my semi-perimeter, was S, and I stored that for B. Just kind of be careful because I do have A and C stored up here, so make sure you don't accidentally overwrite something that you have previously saved. So now that I know what that is, the formula for area is, and this is the long one, it's the square root of your S. Actually, I'm going to store that for S. I'm going to go back in my calculator real quick and store that for alpha S because that makes sense because it's a semi-perimeter. And then to find the area, it's S times S minus each side length. So S minus the 97 times S minus the 92 times S minus the 50. And I'll punch that in the calculator. Again, remember I do have 97 stored for X and 92 stored for Y. So when I throw all this in, even though I'm writing 97 and 92, I'm typing in the calculator X and Y. So let me punch that in real quick. There we go. So I punched all that in and I got 22.88 or bleh, 2287.480. And I stored that in my calculator for B because that does represent the area of B. And then finally, the area of the lake, my total area. And since I have all the areas now stored for A, B, and C, the total area, I'm simply going to type in my calculator A plus B plus C, which alpha A plus alpha B plus alpha C is 7,081.804. And unit is in feet, so area would be feet squared. Finally. Took a long time. That had a little bit of everything. The only thing it didn't have was the law of sines. What a shame. I should have found a way to work that in.